The only quick way to install large rolling bearings and other mounting parts, such as ships' propellers, couplings, or gear wheels, is by a hydraulic method. In the hydraulic method, oil is injected between the mating surfaces. The oil largely prevents contact between the fitting parts. The mounting forces are reduced to about 1/10 of their previous amount. This explains why the parts can be pushed back and forth with a minimum of energy and without the danger of surface damage. As the edge stressings on the ends of the unit are some 50 to 80% higher than the contact pressures in the central area of the fitting joint, the oil film remains briefly preserved. The pressurized oil keeps on being injected until the mounting or dismounting process is completed. After that, the oil escapes. The dry frictional contact is again completely functional inside the unit. Rolling bearings with tapered bores can also be installed with the aid of the hydraulic method. As the unit is being pushed onto the tapered seat, the inner rings are expanded. This reduces radial clearance. This is all part of the manufacturer's master plan and represents a measurement of the fit. This is why the experienced installer will always measure the radial clearance before mounting and then check the clearance while pushing on. Always in the balanced zone, always over the entire bearing width. Here on this spherical roller bearing, you measure across both rows of rollers. You can also measure the axial displacement on the taper instead of the radial clearance reduction. Tables are available from the bearing manufacturer for these measurements. If the bearing is properly pushed on, the oil will be released from the fitting joint. The hydraulic nut still remains under preload. After waiting from 5 to 20 minutes, depending on the size of the bearing, you can release the oil from the press. To bring the piston back into its initial position, first you simply screw on the hydraulic nut a bit more. After that, the nut is removed. The hydraulic method is particularly advantageous for dismounting. As soon as a continuous oil film has built up in the fitting joint, the bearing will bounce right off the shaft. This is why you should always see to it that an axial stop is available. Otherwise, you could face a sizable accident hazard. Here you can see how powerfully the bearing comes speeding off the taper. That axial stop is very important here, only this time placed around the drive-up distance. It works like a bumper. Large bearings don't come whizzing off. These come sliding off the oil film over the piston, guided by the taper. The hydraulic method can, however, only be applied if the required oil grooves and feed ducts are worked into the shaft. That's the designer's job. The installer has to see to it that the edges of the oil ducts are well rounded. Sharp-edged ducts would increase the edge stresses, which might invalidate the whole hydraulic method. When he finishes this, he blows the oil ducts free of chips. The standardized withdrawal and adapter sleeves are mass-produced starting at diameters of 160 millimeters or a little over 6 inches, and supplied with the necessary oil grooves and feed ducts. The withdrawal and adapter sleeves are slitted. The withdrawal sleeves are pressed between the bearing bore and the shaft. They have oil grooves on both the tapered surface and the bore. When installing mounting sleeves, you press the bearing onto the sleeve. This is why you only need oil grooves on the tapered outside diameter. Collecting grooves in front of the slits help you get a uniform oil film on everything despite the interrupted fitting surface. Now let's demonstrate an installation with a tapered shaft seat. Our unit of measurement here will be either the radial clearance decrease or the axial displacement. We must always let the oil out of the fitting joint before we measure the radial clearance. We have to pay attention to the larger axial drive-up distance around the smoothing value on the sleeves. Dismounting. The adapter sleeve nut is released around the axial drive-up and left on the sleeve as a stop. The bearing comes off by itself. The fitting surfaces look as if they were brand new. The hydraulic nut has to be supported for hydraulic installation of a withdrawal sleeve. And this is how it looks in actual practice. The oil is injected by both pumps over tube pieces into the fitting joints. If you can see drops, that means the withdrawal sleeve is floating on the oil film. When mounting the bearing, either the radial clearance reduction, or as in this example, the drive-up distance of the sleeves applies. When dismounting hydraulically, please pay close attention to the axial limit, so you can catch the withdrawal sleeve as it slides off. The support must have bores for the oil inlet. As a rule, bearings with cylindrical mating parts are heated and shrunk on for installation. The hydraulic method is only used for dismounting. Here too, it is an absolute prerequisite for the hydraulic method that the necessary oil grooves and oil inlet ducts be worked into the shaft prior to installation. Should the spherical roller bearing be removed in a horizontal position, then a suitable extractor is necessary. A guide sleeve with a sliding fit for the bearing bore prevents the bearing from tilting in the final withdrawal phase. The oil grooves are not worked into the axle journal on rolling stock axles. When running series dismounting, you can make your life easier by using a fairly elaborate piece of equipment. Here, the oil is pressed from the face between the inner ring bore and the shaft. The bearing can then be removed easily, and what's most important, without damaging the fitting surfaces. The hydraulic method is used for all press-fitted assemblies, such as FAG shipshaft couplings. For this job, FAG supplies a sleeve coupling with an SWK designation, or a flange coupling with an SWKF designation. Press-fitted assemblies for ships' propellers on the tail shaft, rudder press-fitted assemblies or press-fitted assemblies on gear wheels wouldn't be possible without the existence of the hydraulic method.